Hello, everyone. Welcome back to my channel. Today, we're going to tackle a fascinating question that has puzzled many C programmers. Have you ever wondered why the code void p, k, and an a compiles without any issues, even when the code for label a is optimized away due to a goto statement? This might seem like a trivial matter, but it reveals some interesting insights into how compilers work and the intricacies of C programming. In this video, we'll delve into the world of compiler optimizations, labels, and gotos to understand why this code compiles successfully. By the end of this explanation, you'll have a deeper understanding of the underlying mechanisms that govern C programming. To begin with, let's consider what happens when we use a goto statement in our code. When the compiler encounters a goto, it essentially discards all local variables and jumps to the specified label. This means that any code between the goto and the label is optimized away, as it will never be executed. Now, let's examine the code. Void p, ketra, and a. At first glance, this might seem like a typo or some obscure syntax. However, this is actually a valid C construct known as a label address. The en operator returns the memory address of the label AA. The key insight here is that when we take the address of a label using AND, it doesn't actually refer to the code at the label itself. Instead, it refers to the location in memory where the label would be stored if it weren't optimized away. In other words, even though the code for label I might be optimized away due to the goto statement, the compiler still needs to reserve space in memory for the label address. This means that the expression always evaluates to a valid memory address, regardless of whether the label is actually reachable or not. This explains why the code void p and a compile successfully even when the label AE is optimized away. The compiler can still determine the type and location of the label address at compile time without actually needing to execute the code at the label. To recap, here are the essential points from our discussion. When a goto statement is used in C programming, local variables are discarded, and the compiler optimizes away any unreachable code. The end operator returns the memory address of a label, which refers to the location where the label would be stored if it weren't optimized away. Even when a label is optimized away due to a goto statement, taking its address using and still evaluates to a valid memory address. Today, we explored an intriguing question about C programming and compiler optimization. By understanding how labels, gotos, and the type operator work together, we gained insight into why seemingly invalid code can actually compile successfully. If you found this explanation helpful, please like this video and subscribe to my channel for more in-depth explorations of programming concepts. If you have any questions or topics you'd like me to cover in future videos, please leave a comment below.